I'm here during virtual office hours, so check it out, Tuesdays and Wednesdays. But I came across some notes that I did for face-to-face class for section 6.2. So I thought, nobody here right now. Let me make a little recording and show you the notes and show you calculator steps. Let me find it. Okay, here it is. So these are some notes. You can see they are from April 2019. I used OneNote, and they are on chapter 6.1, the standard normal distribution. So in chapter 5, you looked at discrete random variables. Anything that can be counted as 1, 2, 3, very important. Anything that can be counted 1, 2, or 3. Number of books, number of cell phones, number of computers, number of classes, number of pens. Anyway, these are all discrete random variables. In chapter 6, now we're looking at continuous random variables, and lucky for us, they can take on the form of a bell-shaped curve, and thus we can find the probability for these continuous random variables. Examples for continuous random variables are, for example, height, weight, length, distance, anything that cannot be counted 1, 2, 3, that still is a number, but my weight, I can count that as 1, 2, 3. So easy way to say anything that has decimals, that has some kind of range interval, these are continuous random variables, and they can take on a bell-shaped curve, aka normal distribution. A bell-shaped curve is symmetric, and what is important for us, the area under this bell-shaped curve, the cumulative area. So on the far left, we're starting at 0 and going all the way over here. The area under the curve is 1, and you know very well that probabilities cannot be larger than 1. That's why we can use that. So a standard normal distribution, very important. The difference between a standard normal distribution and a regular distribution is the mean is 0 and the standard deviation is 1. So these are some of the properties. The mean is 0. The standard deviation is 1, and as I already mentioned, the area under the curve is 1. Now this horizontal axis, you can kind of understand it. It's the z-score axis that you learned in section 3.3. Z-scores that tell you how many standard deviations you are from the mean. So the mean is smack in the middle, and that means the z-score is 0 there. Now we have negative z-scores and we have positive z-score. A positive z-score, that would mean you are above the mean. A negative z-score, you are below the mean. And if z is 0, then you are equal to the mean. So it's very similar. Think about the empirical rule. What you have to do in section 6.1, I give you, like, for example, the z-score, and you tell me what is the area. Like, the area is equivalent to the empirical rule, for example, the 68%, which is 1 standard deviation to the left and to the right from the mean. So this is considered 68%. Well, that is what we're finding in chapter 6. So here are just normal, the standard normal distribution has a mean, again, of 0 and a standard deviation of 1. The total area is 1, very important. Now, also what is important is that the area is cumulative. So we're it's it's equivalent to percentage. If we were to change it to percentage, we start with 0% on the left, oops, and then we go 10%, 20, smack in the middle. Of course, to the left is 50, then we have 60, 70, 80, 90, and 100%. So keep that in mind when we're looking for z-scores, so that the area is cumulative. The area is then equivalent to the probability. So if we're looking for probabilities of continuous random variables, basically what we're finding is the area under the curve. And the reason why we can do this, again, is because the total area is 1. So here are some examples. There are 3 cases. If I give you a z-score and we're looking for the area to the left, z is less than negative 1.5. So again, this horizontal axis is your z-score axis. So left, then I always good to highlight everything, to color it in. And then what you need to find is the area of the green triangle, which is the probability. First, draw a picture. Draw a bell-shaped curve. Then we shade the area that represents z is less than negative 1.5. We would shade to the left. Of course, that's just a guesstimation. And then you use the calculator. Second, VARS, and you pick number 2, normal CDF. Now the syntax for normal CDF is lower bound, meaning the small number. We're looking at our shading first. So lower bound would be right here. Upper bound is this value right here. And then we enter the mean and the standard deviation. Of course, the mean is 0 and the standard deviation is 1. So in all reality, this lower bound to the left actually is negative infinity. And to the right, we would have positive infinity. However, the calculator doesn't have the symbol infinity. So for rounding purposes, if your lower bound is all the way to the left, aka negative infinity, we're using negative 9,999. So make sure that you use the plus minus key on the calculator and not the subtraction. You will get a syntax error. Plus minus, then enter the 9,999, then a comma, then negative 1.5. That would be the shaded area. Then the mean 0 and the standard deviation of 1. Press enter and you round it to whatever Pearson tells you to round it to, usually 4 decimal places, 0.0668. So here's another example with a probability less than 1.27. So normal CDF, negative 9,999, 1.28. Did I say 7? I meant 8. 0 and 1. So off you go. Okay. Now, case 2 would be the area to the right. Now we're looking at a probability greater than 1.3 for this example. So again, we're shading. We are drawing the bell-shaped curve. We enter all our information, then we shade, and then the low, where does the shading start? The shading starts at 1.3 here. And then our upper limit would be the positive infinity, aka 9,999. So what color is this? Magenta? Magenta color here, 1.3 to 9,999. Then the mean and the standard deviation, enter, off you go. There you have it. Case 3, area in between 2 points, probably the easiest one. Normal CDF, we don't have to deal with 9,999. You go, your lower bound in this case, in this example, is negative 0.2, comma 1.5, comma 0, comma 1, enter, done, you are. So here you can see a couple more examples, and you can stop the video and just practice calculator. These are the examples that you will see in my stat lab. These are actually out of the book. In between, it's about temperature. And now, I don't want this video to be too long. Now, maybe I should stop it and then make another one. Here we go. Stop it. Okay, how do I stop it? Stop video. There you go.